Hello and welcome to the section on data preparation of the advanced course on R programming. Super excited to have you on board, and today we've got an interesting project brief. It's called the Financial Review. Let's have a look inside. You have been hired by the Future 500 magazine. The stakeholders have supplied you a list of 500 companies and would like you to create some draft visualizations for the upcoming online publication. They have requested the following charts: a scatter plot classified by industry showing revenue, expenses, and profit, a scatter plot that includes industry trends for the expenses to revenue relationship, and box plots showing growth by industry. Note that the dataset has numerous discrepancies that need to be addressed before analysis can be performed. Alright, so just in short, Future 500 is a made-up magazine that takes data on companies and then they run some statistics, some analysis around it, and they publish interesting articles about them. So they're after some specific scatter plots and bar charts, box plots that they would like you to create. So they've supplied you a data set, and as you'll see, this data set contains 500 companies or 500 rows, each one representing a company, and some financial information on them, industry information, and so on. And you'll need to prepare this analysis for them, but the key line here is that bottom line, that the data set has numerous discrepancies, and that's what we're going to be focusing on in this section. We're going to learn how to deal with problems in our data, how to convert different types of columns into other types of columns, how to deal with factors. We'll talk about the factor variable trap. We'll talk about cleaning data, we'll talk about replacing missing data, and so on, and what methods you have available to you there. So that's our main focus, and at the end, we will indeed create these charts that they're after. So where do we get this data set? Well, to get the data set, we need a browser, and in our browser, we need to go to superdatascience.com/rcourseadvanced with a hyphen in the middle. And if you scroll down here, you'll see section 2, data preparation. So go ahead and download these files. The challenge file that we looked at just now, the dataset is the main dataset, and bear in mind here when you download it, it'll have a hyphen in the name, so it'll be future-500.csv. In the tutorials, mine doesn't have a hyphen, so it's up to you if you want to correct that. And then Future 500, it's a marked up Excel file. You will see in the tutorials, I will show you when we will need that file when we're talking about different types of missing data. So go ahead and download those, and I will see you in the next tutorial. Can't wait to get started on this. And until next time, happy coding. Hello and welcome back to the advanced course on R. In this tutorial, we're going to import the dataset into RStudio. So as you can see, I've got RStudio open in front of me, and I encourage you to follow along so that you can have the same code on your screen as well. Alright, so let's get started. First things first, we're going to get the working directory for our RStudio. As we can see, the working directory here is users Kirill Ermenko. So that's not where I have stored the file. I stored the file in a folder on my desktop. So I'm going to set the working directory to that so that I can work in that folder right away. I'll show you how to do it both on Mac and Windows. So we'll start with Mac. I'm going to say set working directory. And here in quotation marks, I'm going to say users. So similar to what we see here. Actually, let's copy that. Users /Kirill Ermenko, then desktop, then R programming advanced. Alright, so that's how you set the working directory on a Mac. Let's run this line. As you can see, the working directory has been run, and let's just check it out. It has been set to the correct folder. That's good. So this is for Mac users, and if you're watching and doing these tutorials on Windows, then the procedure is a bit different. You need to type in set working directory, and here the path should be specified. Instead of using forward slashes, you need double backslashes. So for instance, it would be C /users /Kirill /desktop /R programming advanced. So depending on where your file folder is stored, so in this case it's on the C drive and the users folder in the folder of my name, then desktop, and then R programming advanced. So I'm just going to comment this out so it's not in the way, but if you're using Windows, then that is the format. On Mac, that is the format. Alright, so then just make sure to run get working directory to confirm that the working directory has been changed. And now we're going to import our dataset. So as you can see, we have nothing in our global environment here. And let's go ahead and use the read.csv function, which we are well familiar with now. Now we're going to type in the name of our dataset, which is future 500.csv in quotation marks. And we're going to assign what read CSV returns to an object, right? So we're going to store our data set in this data frame, which is called fin. Fin stands for financial because we're dealing with financial data. So I'm just going to use the name of the data set as fin. So if we run this line, as you can see, we've got an object, we've got a data frame with 500 observations, 11 variables. So it's got some information there, but we don't need that because we have other ways of exploring this data set now in R. So let's proceed to that. The first way we know is to just run the name of this data set, and that'll bring it all out here. As you can see, there's a lot of lines, way too many for us to look at in this way. So we're going to use some tricks that we know when dealing with data sets. We're going to look at the top, a certain number of rows. So we just look at head fin. And let me expand this. We won't be needing this window much in this section of the course, so we're just going to keep it closed like that. So if I run head fin, there you can see we've got the top 6 rows of our data set, and it's got all the columns, so it kind of gives you a good understanding of what's going on. Also, we can look at the tail of fin. Then we get the bottom row, so we can see indeed there's 500 and there hasn't been any row shifts or column shifts. Everything looks okay. So it's always good to check. And if you want to check a few more rows than 6, then just say here, just pass a parameter, let's say 10, then it'll give you more rows. Same with head, you can check more rows that way. And now let's have a look at the structure of our data set. So str fin, there we go. We've got a quick description of every column, what it is. So that's an integer, that's a factor, that's a factor, that's an integer, factors, integer, factor. And finally, let's look at summary fin. So there we go. We've got some stats on every single one of these columns. So all of this should be already familiar to you from our basic course on R programming. And today, what I wanted to focus on is that we've got a lot of factors here. So we've got a lot of factors that we're dealing with, and factors are going to be quite important for us in this section of the course on data preparation. So in the upcoming tutorial, we're going to have a quick refresher on factors because we really do need one just so that we're all on the same page when we're dealing with factors. But other than that, the dataset has been imported into R, and if you would like to start playing around with it, you can do so. And I look forward to seeing you on the next tutorial. Until then, happy coding! Hello and welcome back to the advanced course on R programming. In the previous tutorial, we loaded up our dataset into RStudio, so we can see this line over here, and we had a look at the different snapshots of our data. So we looked at the top rows, we looked at the bottom rows, we saw that there's indeed 500 rows, we saw what columns we have, then we looked at the structure of our dataset, and we looked at the summary. Now from the structure, we noticed that there's quite a lot of factors that have been recognized in our data, and that's why today we're going to talk about factors. We're going to refresh on the knowledge on factors. We're going to find out what they are and how to deal with them in R. So it's going to be a quick recap, and I think it's going to be useful because further down in this section, we're going to be dealing quite a lot with factors. All right, so what is a factor, and why is R recognizing some of these variables as factors? Well, a factor is basically a categorical variable in R. Now, let's look at one of these as an example. Industry, for instance, right? It's a factor with 8 levels. And if we go down here to the summary, we'll see that there's IT services, there's health, software, financial services, construction, government, and that makes 6 already. So there's 2 more in here, and one of them is an empty category. So the empty category that we see here as well. So here you have a few examples. You've got the empty category as an example, in construction, and then there's more. And then you've got these numbers. Well, these numbers are the identifiers that R assigns to each one of the categories. For instance, the empty category has been assigned the identifier of 8, and construction has been assigned the identifier of 6. And that's basically how R deals with these categorical variables, because it is a programming language and all happens in your computer. For R, it's just easier to deal with numbers rather than with words. For us humans, it's easier to deal with words like construction, IT services, health, and so on. For R, it's just easier to deal with numbers. And this is actually going to be an important point that's going to come up again in one of the future tutorials. So just remember that R does deal with factors in a numerical sense rather than in a word sense or character sense. And the way R picks up factors is if R cannot recognize it as an integer or as a other type of number or a Boolean variable, some kind of a variable that has meaning to it, then R just recognizes it as a category, as a categorical variable. And most commonly that happens with words, with characters, because for instance here we've got names of companies, right? So here we've got all the names of companies, and R has also recognized that as a factor. So it's a factor variable with 500 levels because every single name is unique in our data set, and therefore it's created this factor variable, which doesn't really bother us. That's just how R is going to deal with it. It's going to treat it as a categorical variable. If we wanted to, we could change it back into a character, because ultimately it's not really a category, it's just the names of the companies. Then if we go down, we find something interesting. So inception is the year when the companies were created. And here R has recognized that as an integer. And same thing, ID. So ID is the identifier of the row, and R has recognized it as an integer. Now, if we really think about that, do we really want ID to be an integer? Do we really need a minimum? Do we need a median, a maximum? Are we going to perform arithmetic operations with this variable? No, it's just a numeric variable that is assigned to our rows, and we don't want to perform any arithmetic operations with it. So it probably is better if it's recognized as a factor, and that'll be less confusing to us. And same thing for inception. We're definitely not going to add these years. We're not going to subtract any of these years. For us, it's just going to be more convenient if we see this variable as a factor. So those are two examples of when a variable is not recognized as a factor by R, but we want it to be recognized as a factor. Now, another example here that you'll see is an example of the opposite. So here we see a state is okay as a factor, city is okay, and then we see revenue is recognized as a factor, and expenses are recognized as a factor. And same thing for growth. So while profit is recognized as an actual number, these three are not. And let's have a look at why this is happening. Well, this is happening because, for instance, in revenue, we've got this $sign and we've got these commas, which R cannot convert into a number. It doesn't know that this is a number. It's recognizing it as a character, and then it's converting it to a factor. And then expenses, same thing. We've got the commas, we've got the space, and we've got the word dollars. And that is preventing R from recognizing this variable as an actual number. And finally, in growth, we've got, what do we have? We have this percentage sign, which is preventing R from recognizing this as a number. So that's an example of when something is recognized as a factor, but in reality, it should be numeric. And that is also something that we're going to need to fix up. So in this tutorial, we're actually just going to correct the first thing, because it is actually very easy to change something from a non-factor to a factor. So let's go ahead and do that. So here we're going to say changing from non-factor to factor. Let's have a look at how we do that. So here we've got a variable or a column which is fin $ID, and that gives us access to the ID column. So as you can see, there it is as a vector. And now we're going to turn to a factor. Just use the factor function and put it around fin ID. We run that. Now you can see that same thing. This is the vector for that column, but at the end it actually has levels. And as we said, levels is a giveaway for factors. And now we're just going to override fin ID with our variable over here. So with our new factor variable. So now if we look at a summary for fin, you will see that ID is also recognized as a factor, and we can confirm that by looking at str for fin. So here you can see that now it is also a factor. So let's go ahead and do the same for inception. So we're going to say fin $sign inception is going to be overridden by factor of fin $sign inception. We run that and we look at, let's just go to str right away. Here you'll see that inception is now a factor. So it's as easy as that. And if we look at the summary, so let's just copy this over here. So here you can see that if you look at inception, now it's not giving you the minimum, the maximum, the median, and so on. It's just giving you the categories that you have. And you can actually tell that there's 93 companies that were started in 2011, 83 in 2010, 80 in 2012, and so on. So it's much more convenient like this, and it's not confusing. And moreover, it will allow us to categorize the companies by the year of their foundation. So there we go. That's what factors are and how to convert a non-factor to a factor. Moving forward, we'll talk about some other interesting aspects of dealing with factors, and I look forward to seeing you on the next tutorial. Until then, happy coding! Hello and welcome back to the advanced course on R programming. In today's tutorial, we've got a very interesting and even intriguing topic. We're talking about the factor variable trap, or the FVT. So the factor variable trap comes into play when you're trying to convert a variable from a factor, or a column from a factor, into a non-factor. We've already talked about the other way. We've talked about converting from non-factor to factor. It's pretty simple. You just use the factor function. But today we're going to talk about how to convert factors into non-factors, and that's where this pitfall arises. Now, bear in mind, if you do search for factor variable trap on Google, you probably won't find much, because I came up with this term just for these tutorials. It's a known phenomenon, but it isn't very well publicized. It's not much discussed, and I really don't know why not enough attention is being brought onto this issue. And that is because it is a major pitfall that a lot of programmers end up falling into. And just simply by covering it in this tutorial, I'm sure you will get the right knowledge and preparation to avoid this pitfall and know how to deal with it when you come across it. So without further ado, let's dive straight into it. Let's see what we're talking about here. A few minutes, we're going to forget about our data set that we've been working with, and we're going to create a new vector. So we'll create a vector A, and into that vector, we're going to put the following values. So we're going to put in 12, 13, 14, and then we'll just put in 12 and 12 again. So 5 values, all in quotation marks. If I look at A now, you'll see that we've got the 5 values here, but because of the quotation marks that we specified, they are being stored as characters and not as numerics. And I can confirm that by just looking at type of A. You'll see that it's a character. Now, what would we do if we want to get to the bottom of these values? So we want to actually deal with them as numerics rather than as characters. So we want to maybe add them, subtract them, and perform other arithmetic operations. What would we have to do with A in order to convert it to a numeric vector? Well, it's very simple. We would create a vector B, and into that vector, we would put the result of calling the following function as numeric. As numeric converts something into a numeric. And here we're going to pass on the vector A. So if we run that, and now we look at B, you'll see that we've got the same values, 12, 13, 14, 12, 12, without the quotation marks. And if I call now type of B, you'll see that it's a double. So a double is a type of numeric, and therefore we can perform arithmetic operations if we want to with this vector. So that's a great way to convert characters into numerics. So here we're going to say 4 characters. But now the question is, how do you convert factors into numerics, right? So let's say converting into numerics, just so that there's no confusion, because the factor variable trap actually has nothing to do with this part. It's only for the second part. So here we're going to say converting into numerics for factors. All right, so let's have a look at this. How would you convert a factor into a numeric? Well, the first thing is we need to create the factor, right? So let's say we have a factor z, which is going to be exactly the same as vector A. So let's take that, with the only difference that it's going to be the factorized version of this vector. So what does that mean? Well, it basically means that we're telling R, could you please take this vector and treat it as a categorical? So take these categories and create a factor for us where you've recognized these different values that you find in this vector as categories. So if we run this line, we've got our vector z. If I run z now, you'll see that we've got 12, 13, 14, 12, 12. And bear in mind, the quotation marks are not shown here. what you also see is the levels. So R can see the different levels because R knows that it's actually dealing with categories. So it's just not showing you the quotation marks here. But at the same time, it appreciates that these are indeed categories. So it's not recognizing them as numbers. But what can be confusing to us is that we might think that these are recognized as numbers, right? So what would we do if we wanted to convert them to numerics now, right? So if we said, okay, we've got this factor variable, how do we get rid of this factorization? Just convert to a normal numeric vector. We might try to do the same thing as we did over here. We might say we want a new vector y, and we want to say as numeric and vector z, right? And that's your first inclination. What you want to do is, all right, I want to get to the bottom of these numbers. I want to be able to deal with them not as a factor. I want to deal with them as a numeric vector. How do I do that? I'm going to run as numeric of z, run, and voila, look at y. Whoa, very different, right? 1, 2, 3, 1, 1. What's going on here? Why is it not 12, 13, 14, 12, 12? This is completely not what I wanted. And if I look at type of y, right, it's a double. It's exactly what I was expecting here, like type of b, type of y. So we did exactly the same things. So here we did b as numeric a, y as numeric z, but the result is completely different. What happened here? Well, what happened is we picked up the actual factorization of the variable rather than the factors themselves. And to understand that a bit better, let's run a quick line over here after we created z. Let's look at type of z. If you look at type of z, it's actually integer, right? So z is being seen as an integer, but it doesn't mean this integer that's inside here. The integer that is z is the factorization integer. So let's understand that a bit better, because this is basically the essence of this whole factor variable trap. So I'm just going to create that line over there. And if I look at z again, so this is z, 12, 13, 14, 12, 12. What R does is it says, okay, levels 12, 13, 14. And as we discussed previously, what a factor is basically R seeing these as categories, or seeing this vector that it can be broken down into categories. And indeed it can. There's a category of 12, it comes up 3 times. There's a category of 13, comes up once, and a category of 14, which also comes up once. And so what does R then do? Then it shows these categories as levels. Well, they're called levels. You can call them categories. And then in the back end of R, what it does is it assigns just numerics to them. It says this is category number 1, category number 2, category number 3. And therefore, when we look at it, we see 12, 13, 14, 12, 12. When R looks at it, it sees 1, 2, 3, 1, 1, because that's how they have been coded, right? It doesn't matter what numbers I have here, or if I have countries here, or I have names, or anything that can be categories. What R is doing is it is coding them with numbers. So that is number 1, category number 1, category number 2, category number 3, then category number 1 again, and number 1 again. So when you're trying to convert using the as numeric function, what you will get is the categories. So that's why you get the 1, 2, 3, 1, 1, rather than the actual numbers that you want. And that is the essence of the factor variable trap. That programmers who are not aware of this, or analysts or data scientists who are not aware of this, can easily fall into this trap. And the worst part is that if you're expecting a numeric and then you get this and you don't double check your work, you can proceed to using these wrong numbers in your results and you'll get completely incorrect results. So how do we avoid this factor variable trap, or how do we actually convert z into a numeric in this case? Well, the correct way to do it is to first convert z into a character and then convert it into a factor. So what we would do is we would say as.character and we would say z, right? If we run that, then you got your 12, 13, 14, 12, 12 without the levels. And if I go as.numeric around that and I put that into variable x, and now I look at x, you will see that 12, 13, 14, 12, 12 have been released. So from a factor, they turned into a character. From a character, they turned into a numeric. So basically, after they've turned into a character, we're repeating this process. And so now if I look at type of x, you'll see that it is a double. So keep that in mind. This is the factor variable trap, that you cannot convert something that is a number that should be a or is recognized as a factor that should not be recognized as a factor, you cannot convert that right into a number right away, because you will inevitably and inadvertently pick up the factorization values, right? So you'll pick up the numbers that R uses within its backend for itself, rather than the numbers that you're after. If you want the numbers that actually are contained in these quotation marks, then you first need to convert it to a raw character, so as character, and then convert it into numeric. So I know this may be a bit overwhelming at first. Have a play around with that, try experiment, create a few of your own vectors to really understand this better, and then we will start slowly implementing this in our data preparation phase. So basically in the following tutorials of this section, this is a very important part, and is going to play a big role in how we approach conversion of the remaining columns into their correct types. Hope you enjoyed this tutorial, and I look forward to seeing you on the next one. And until then, happy coding! Hello and welcome back to the advanced course on R programming. In today's tutorial, we're going to continue exploring the factor variable trap, and we're going to look at a more relevant example, something that will resonate with us more. In fact, something that comes directly from our dataset. So once again, let's look at our dataset, which is fin, right? Here we've got some variables. So we're going to be specifically looking at revenue, expenses, and profit. And let's look at a summary, or let's look at str first of fin. Here we'll see that these three out of them, two are recognized as factors. And so ultimately what we'll need to do in this data preparation phase, we're going to need to convert these into non-factors, into actual just numbers. However, dealing with these is a bit more complex. We're going to need to know how to remove the commas, the dollar signs. So we're going to need some extra functions that we haven't learned yet. So we'll cover off those in the coming tutorials. What we're going to do for now is we're going to deal with profit. And here you can see that it's not a factor, right? So we're going to pretend that it was a factor initially, and then we'll learn how to deal with it. It's just going to make this example, it won't overcomplicate this example, make it simpler for us to understand. It'll allow us to focus on the factor side of things rather than introducing new functions right away. So let's do exactly that. We're going to take a fin, and then we're going to take the profit variable here, and we're going to replace it with factorization of fin profit. So basically we're creating this artificial example for ourselves. Let's do that, and now let's have a look at strfin. So here you can see that same thing as previously. Like if I look at, let's do this first. Let's look at the top 6 rows. If I look at the top 6 rows, you'll see that you can't even really tell the difference. It's actually the same. It's got the values here just as we had before. So if I look, scroll up here, those are the values, same values here. And if I look at the structure of this data set, now you can see that it is being recognized as a factor. So that is the difference. It's not being recognized as numbers anymore. It's being recognized as a factor. And so it's being assigned these different levels. So there's a total of 498 levels in this factor, and they're being assigned these numbers. So these are the numbers that R uses to deal with the factor in his backend. These are the numbers that we are seeing. So let's say now we want to go ahead and convert this factor into a numeric. So that, because now if I look at summary for fin, I'll see that profit is being recognized as a factor. I don't want that. I want to see, the mean, like here, median and stuff like that. I want to be able to perform arithmetic operations with profit and so on. So how do I convert profit? How do I convert this variable over here, profit, into a non-factor variable? Well, the first inclination, as we discussed in the previous tutorial, first inclination of a novice, our programmer, or somebody who hasn't dealt with this issue before, would be to say, okay, I'm going to take fin $profit, and I'm going to convert to a numeric as a numeric. And then because I already know that what this function returns, I'm just going to right away put it into fin $profit. So I'm going to override my existing values in fin profit, which are for some reason recognized as a factor, which looks like a character. So we're going to convert it into numeric, and we're going to then just put it in there. So if I run this line, everything should be okay. So if I look at strfin, what do I get? I get that it's a number, it's no longer a factor. And so now let's look at the top rows of this dataset now. Now what we can see is that top rows are completely different. the top rows, the profit is $342, 476, 348, completely different to what we had here, right? So if I scroll up, it used to be $8,553,827. This was 13 million, 8 million. So this was in the millions of dollars. Now our profit is in just the hundreds of dollars. What happened here? And moreover, can we revert it back? Well, the answer to the last question is no. This data frame has been ruined. What have we done here? So what we did is, because we use the as numeric function, instead of dealing with these values that are the actual values that we want, R is looking at the representation of the numeration of the categories. So these identifiers that R has come up with for the categories, that's what R is applying the as numeric function to. And then that is now what we see in our profit, and that is what is being displayed here. So, and the worst part is that there's no way of going back. So, well, probably that's not the worst part. That's the second worst part. There's no way of going back to the actual profit figures because they're gone. We just by doing this line, we've overridden our data frame, that whole column in our data frame. And well, the worst part is that if you don't pick this up while you're dealing with it, then you're going to report, or the analyst is going to report numbers to the executives or to his manager, which are, instead of being in millions, are in the hundreds of dollars. Completely different picture, completely incorrect result. So as you can see, this puts it into perspective. This is a major issue that needs to be recognized and needs to be avoided. So you need to avoid this pitfall and just make sure that you perform your conversions correctly, and we will practice that in the coming tutorials. So for now, what I'm going to do before we end this tutorial, I'm just going to comment this part out, so the FVT example, or in fact, I'm going to comment the part out that is actually dangerous, that's overriding things, so that it doesn't bother us when we rerun this whole script. And I'm just going to say dangerous, and same thing here. And now I'm just going to rerun this whole script so we do have the correct data set with the millions of dollars here. So when we proceed to the next tutorial, we have the right data that we're dealing with. Okay, so I really hope that that puts it into perspective, and you can see that why it's important to understand the factor variable trap and avoid it. And in the next tutorial, we will proceed with our data preparation. And I look forward to seeing you then. Until next time, happy coding. Hello and welcome back to the advanced course on R programming. Today we're going to start dealing with the factor variables, the revenue and expenses ones, and we will learn how to convert them into non-factor variables, because as we can see, they are just numeric variables. They contain information on dollar amounts, so they should be stored as such, so as numeric data. So as we can see here, profit is stored like that. So that's what we want to do with these variables, and also with the growth variable. So we're going to learn how to do that. And for that, we're going to need two functions. We're going to need the sub and the g sub function. Okay. So here I'm just going to type in sub and g sub. So what are these mysterious functions for? Let's call the question mark, and let's have a look here. So let's zoom in over here, and what we can see here, so sub is the function and g sub is the other function. So what they do is they look for a pattern, they replace it, and then that's x is where to look for that pattern. We're not going to worry about the other parts of this of these functions. And the difference between sub and g sub is that sub replaces just the first instance, g sub replaces all of the instances. So let's have a look. Here you can see sub and g sub perform replacement of the first and all matches respectively. Pattern, matching, and replacement. So let's go ahead and try these functions out. So what do we want to do? Well, we're going to be actually dealing with the g sub function, because in our case there's no situation where we want to just replace one instance of something. We will be replacing the dollar sign, we'll be replacing the commas, all of them, and then commas here, then the word dollars, the space, and the percentage sign. So in all cases, we want to replace all instances of what we find. So we're just going to be dealing with g sub. So let's see how we can work with g sub. Let's say we want to start with the expenses column, for instance. So what are we going to do here? We're going to say fin dollar expenses, and we want to replace that with G sub. All right, here we're going to specify the pattern. What pattern do we want to find? We want to find this pattern. So space and then dollars. So let's paste that here. And we want to replace that with nothing. We want to replace that with an empty, just empty quotation marks, because we want to just basically remove it. And then we're going to say comma. Where do we want to find that? We want to find that in fin dollar expenses. So once again, this is the pattern that we're looking for. This is what we're replacing it with. And this is what we're analyzing, where we're searching for that pattern and replacing. So if I run this line, what that just did is it replaced all of the expenses there. So let's go ahead and look at that top line. You'll see that in expenses, we no longer have that word dollars. No space, dollars. We don't have that. So now we want to replace these commas, right? We want to replace the commas in the expenses column. So let's go ahead and do that. We're going to just copy this line, and here we're just going to say comma. And if I run this and I look at the top, you can see that expenses no longer has the commas. And the interesting thing here is if I look at str fin, you will see that expenses is no longer a factor, it's a character. So that's an important thing for us. We're going to use that to our advantage when we're continuing with this variable. But let's just remember that for now, that it's character, not a factor. And let's deal with the revenue variable. All right, so revenue is going to be a little bit different. What do we want to replace in revenue? We want to replace the dollar sign. So let's go fin dollar revenue. We want to replace with using G sub. We're going to replace the dollar sign. So if I type in just dollar sign, and then I say with nothing, and then I say fin dollar revenue, if I run this and I look at the top, what you'll see is the dollar sign is still there. What happened? Why doesn't it get replaced? Well, that is because a dollar sign is a special character in R. As you can see, we're using it here, and there. It has its own implications. And if you want to find a dollar sign inside of a string, so if you want to actually address the dollar sign in its character meaning, then you need to create an escape sequence. And now, without going into too much detail, the way to create an escape sequence for a dollar sign is to put a double backslash before the dollar sign inside the quotation marks. So if I run this now and I look at fin, you'll see that the dollar sign has disappeared. Now, there are a few symbols that will need a escape sequence before them. And so basically, if you run into, the way to deal with it, the best way is to, if you run into something like an issue like this and you are suspecting that you're dealing with a special character, like a dollar sign is a type of special character, well, then just look up the escape sequence. So just Google for escape sequence for that specific sign in R, and most likely it'll be something similar. So that is how we replace the dollar sign. And now we want to replace, same thing we want to do for commas, right? So let's do that, G sub, comma, and then with nothing, and we're going to say fin dollar revenue. So if I run that, I look at the top, there we go. So we've got revenue, very nice. So if I look at str fin again, you'll see that both of these variables are now characters rather than factors. And what does that mean? That means that we'll soon be able to very easily turn them into numerics. All right, so what are we going to do now? Now you can actually pause the video and you can do the same thing for growth. So it would be a good practice exercise if you get rid of this percentage sign on your own for growth. Otherwise, if you want to continue and see how I'm going to do it, just keep watching the video, and I'm going to do it actually right now. So I'm going to go fin dollar growth, and I'm going to go G sub, and I'm going to look for percentage sign, comma, nothing, and in where am I going to look for it? In fin dollar growth. Yep. So if I run that and I look at the top rows, so I go head fin, you will see that growth no longer has that percentage sign. So there we go. We've corrected 3 columns, revenue, expense, and growth. And now all we need to do is convert them from character into a numeric. And as you remember, this is going to be much easier than converting from a factor into a numeric, because basically what we just did, remember this part where we had a factor and we had to first convert it into a character, and then we could only convert it into a numeric, right? So in the factor variable trap. Well, by using the gsub function to replace things, what we actually already did is we did that transitional step. We completed this step. So instead of using just as character, we used gsub, which performed some conversions, and gsub actually did that conversion. Apart from replacing stuff, what it did is actually converted the factor into a character for us. So basically this step has already been done, and that's why we're seeing characters here. All we have to do is now apply the as numeric function. So in this case, it was like it's a bit concealed, but we're still doing that same method. We're still first converting to a character. The factor is being converted to a character, and then it's being converted into a numeric. So now we're going to do that. Expenses, right? So if I run that, that should be it. And here I'm just going to be a bit lazy and change this to revenue and this to revenue. This is going to be growth. All right, so if I run this, now I can look at fin. So now you can see that it's numeric, numeric, numeric. It doesn't matter that this is integer. It's pretty much the same thing. It just means that it's more specific, that there's no doubles in there or anything like that. And here we're going to look at summary for fin. So if we look at summary for fin, you can see that it's beautiful. Now all four of these variables, revenue, expenses, profit, and growth, are being recognized as actual numeric variables, which is exactly what we wanted. We can now deal with them as they are. So just to recap, we did follow the same process which we discussed here, where a factor variable has to be first converted into a character, and then it can only be converted into numeric to avoid the factor variable trap. In our case, because we use the gsub function to replace things, this is already incorporating our conversion into a character, and then we are converting the same variable using the as numeric function into an actual numeric. So that's how this works, and that's how we avoided the factor variable trap in this example. And I hope you enjoyed this tutorial. I know it was a bit of coding this time, but definitely worth it. We've gotten our variables as we want them. And I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the course on our program. Today we're talking about dealing with missing data. So missing data is a very common theme in data science or analytics, and it happens because data sets sometimes not full, or there might have been some errors while it was being supplied, or somebody forgot to put something in, or just basically that data was not collected in the first place. So dealing with missing data is important. You need to know what options you have and what approaches you can take in order to fix the data or maybe not fix the data, and what you do in every different case. So today we'll quickly overview what exactly are those options that you have. All right, so option number one is the best option when you can predict the missing data with 100% accuracy. And we'll see examples of this in our tutorials in this section. For instance, if the field for state is missing, but you know that the city is New York, well, in that case, you know for sure that the state is actually also New York, right? Or if the city is San Francisco and the state is missing, then the state is actually California. So things like that. Or for instance, another good example is where you have two variables and you can derive the third variable based on that. So for instance, if you know revenue and expenses, but the field for profit is missing, well, in that case, it's very easy to derive profit because profit is actually just equal to revenue minus expenses, assuming that there's no issues in the data that was supplied originally and that there were no errors or there was no fraud. Then that is the calculation that you would perform. So that is the best case scenario when you can predict the data with 100% accuracy, and then it's as if you never had any missing data. Then the next option is leave the record as is. So don't change anything about it, just leave that cell empty. And when would you use this? Well, this approach would work if, for instance, that specific field is not important for your analysis. And we'll see an example of this. If the field is not important for our analysis, then it doesn't really matter that it's empty. The other option is that if the algorithm that you're going to be applying to your data set, and this is a bit more advanced, if the algorithm you're going to be applying, it actually already incorporates some methodologies to account for missing data and to correct that inside the algorithm. And in that case, also leaving the record is okay, because the computational method will take care of it. Next is remove the record entirely. So sometimes you're missing some critical data, and in that case, when you cannot restore that data, the only option that you might have left is to completely remove that whole row from your analysis in order to keep your analysis. So in order to keep your algorithms working, or to keep your approach working, you have to remove this one record. And this has a drawback. The drawback here is that your analysis becomes less significant, or has a smaller sample, and that can have certain implications. So if you're fine with sacrificing a few rows here and there, and it's not critical for you to have information in every single record, then this could be another approach that you might apply. Next one is replace with the mean or median. This is a very popular approach, and we're going to also see an example of this in our dataset, in our tutorials. This is going to be one of the main approaches we're going to be relying on. And so basically here you can say that if, for instance, you have lots and lots of rows and they all have a certain value for revenue, and then one row is missing that value, then you can calculate the mean or the median and put it in there, and then proceed with your analysis. So mean is an okay option, but usually median is preferred, because median is less affected by outliers. All right, so that's another approach. And then we've got fill in by exploring correlations and similarities. So that's kind of a step up from mean or median, where you can actually create regressions, or you can create different models that will, within your data set, predict what the values for those empty cells could have been. So that is an extra step up from mean or median. And finally, introduce a dummy variable for missingness. This is a very interesting approach, where you actually introduce a new variable, and where some data is missing, you give it a yes flag. When it's not missing, you give it a no flag, and you explore the correlations of that variable with the outcome that you're looking for. So this is also a more advanced approach, and we won't be looking at it in these tutorials. All right, so now let's have a look at our actual data set and see what data is missing in there. This is going to be quite an interesting exploration. So I'm going to move to the data set. Let's zoom in a little bit here. And here you can see the same exact data as we see in R, but it's actually in Excel, because here I could color it nicely and show you around. All right, so here's the data set, and let's go from top to bottom, left to right. So what do we have here? We've got employees, right? So in this case, what we can do, this missing data, so the red represents missing data. What we can do here is we can replace or proxy it with the industry median. So what I'm going to do is I'm going to, as we go through these, I'm going to show comment. So here we can just proxy with the industry median. We can take the median for this whole column and just put it in there. And because we have this classification by industry, we can simply look at only the companies that are in retail, and that way we'll get an even better approximation than if we took the whole median for the whole row. And also median is better because if we took the mean, then there are some outliers here. So companies that have 1,500 employees, and there's another company here. As you can see, there's also a few more missing values as you scroll through the data set. There's a company here with even more employees, but basically that's the point, that some outliers with huge numbers of employees will skew the mean, but with the median, they won't affect it that much. Okay, so what else do we have? Well, let's proceed to industry then. In this case, what can we do here? Here we can either keep it empty, right? Or we can research the value, or we can remove the line entirely. And in our case, industry is an important factor for, or an important variable for our analysis. So in our case, we're going to assume that we can't research the value. So we're going to just remove the records with the missing industry. Then inception, or the year when the company was formed, Here what you can do is you can either keep it empty or research it or remove line, just like with industry. And bear in mind here, you cannot proxy it. You can't just take the average or the mean value for the inception for all the other companies, because it doesn't work that way. It's supposed to be a numeric value. It's actually more of a it's more of a category, so you can't just take an average of the year of inception and put it in here. So you either research it or you just remove the line and keep it empty. In our case, it's not going to be that much of an important variable, so we're going to just keep this line as it is. All right, state. What can we do with state? Well, this is that example that we talked about, that here this can be corrected with 100% certainty. We can say that the state is New York here. And this is another example that here with 100% certainty we can calculate that the expenses is the revenue minus profit. So we know that profit is revenue minus expenses. If we solve that equation for expenses, we get expenses equals revenue minus profit, so we can easily calculate it here. And then we've got a line here where we've got revenue, expenses, and profit. All three are missing. So what can we do here? And actually growth is missing as well. What can we do here? We can proxy all of these with industry medians. So we would proxy the revenue with the industry median, the expenses with the industry median. The profit we would have to calculate, because once we know revenue and expenses, profit is 100% certain. And growth we would also proxy with industry median. So this is how we deal with different missing elements in our data. As you can see, we're applying different approaches in different situations. Some places we can proxy, some places we can predict or find out with 100% certainty. Some places we just have to remove the rows, and some places we can keep them. So it all depends on your understanding of the data set and the methods that you're going to be applying for analyzing it. And once you know all of that, then you can make these judgment calls on what is going to be replaced, what is going to be kept. All right, so that's our overview of missing data, and we're going to get started on all of this in the next tutorial. And I look forward to seeing you then. Until next time, happy coding. Hello and welcome back to the advanced course on R programming. This is going to be a quick tutorial, and we're going to understand what is a missing value. In R, missing values are represented by the symbol NA. So this is a special variable. As you can see, it's highlighted in red. So let's read a little bit about it. If we type in (NA) and then look at our pop-up window over here, and we zoom in a bit, you can see that here NA stands for not available or missing values. And NA is a logical constant of length 1, which contains a missing value indicator and some additional information which we're not going to go into right now. So what is an NA in that case? Why is it a logical? So we already know a couple of logical constants, right? We know the true and false. So now they're telling us that there's a third one, which is an NA. So let's have a look at that in a bit more detail. So we already know that we have true, which is a logical constant. We have false, which is a logical constant, and the representation for true is actually a 1. The representation for false is 0. But now we've been told that there's another one, a third logical constant, which is an NA. So how do we go about this? How do we understand this? Well, the thing is that in programming, oftentimes, especially in data science, data mining, analytics, oftentimes it is the case that a value is missing. So for instance, there's no numeric value in a column that there's supposed to be, and that value is missing. Or there could be a Boolean column where there could be true or false. Or what happens if the value is missing? Let's have a look at an example. Let's answer the question, how many cars does Mike have, right? We could answer the question, Mike has 1 car, right? We could answer the question, Mike has 2 cars or 50 cars, or maybe Mike has 0 cars, right? So basically, these can be looked at as, or if we pose a question as, does Mike have a car? And the answer is true. Or does Mike have a car? The answer is false. But what if we don't know the answer? If we don't know whether Mike has or doesn't have a car, how do we populate that field in that case? We can't say false because that would mean he doesn't have a car, right? So we would have to say NA. That's the logic behind the NA. And this kind of ventures into the field of 3-valued logic, or ternary or trivalent logic, which is a whole area of mathematics. But we're not going to venture in that deep into there. We're just going to look at the implication this has on programming. So for instance, what can I do with these variables, right? What can I do with the existing logical constants that we know? Well, I can compare them. I can say true, right? I want to check if true is equals to false, right? Let's have a look at that. The answer is false. True is not equals to false. Makes sense. I can check if true is equals to 5. True is not equals to 5. Can check if true is equals to 1. That'll be true because that is the representation of 1. I can check same thing for false. I can check if false is equals to 4, for instance. It's not. If I check if false equals to false, the answer will be true, right? Because false does equal to false. And I can check if false equals to 0. The answer is true because false is 0. That's how it's represented in programming. But now, can I do the same thing with an A? Can I check if an NA equals to true? What do you think the answer is here? Well, you'd think the answer would be false, right? So that NA is not equal to true, so it'd be false. But in reality, the answer is NA. So what if I want to check if NA is equals to true, to false? Again, it's an NA. If I check NA is equals to 15, is also an NA. Can I check if 15 equals to NA? Also NA. Can I check if an NA is equals to an NA? Surely this has to be a true, right? And once again, we get an NA. And why is that? Well, that is because we're comparing a missing value to something else. So a missing value compared to true or to false, we don't know what the result is. So the result is again a missing value. And even when you compare a missing value to a missing value, the result is going to be a missing value. That's how programming works. It's very similar to what a null is in SQL, if you know SQL programming. So NA, you can look at an NA as a null in SQL. And it basically represents a missing value. You cannot compare an NA to anything else, including another NA. And that poses some implications that we're going to have to deal with going forward in these tutorials. But for now, that's all I wanted to show you about the NA, just to make sure that we're on the same page, that it's a third type of logical variable, and it's very specific and it's very special in the way that how it compares to other things, and that obviously we're going to have to deal with it in certain special ways. And I look forward to seeing you on the next tutorial. Until then, happy coding. Hello and welcome back to the advanced course on R programming. In one of the previous tutorials, we discussed missing data and the options that you have to deal with it. And here we've got a spreadsheet. The actual data that we are working with is mapped out on what we're going to do with these different missing elements of our data. So sometimes we'll proxy it with the median. Sometimes we're going to remove the whole row. Sometimes we're just going to keep it as empty. Sometimes we can predict it with 100% certainty. And here again, we're going to be proxying it with medians. So now we're going to proceed to R and find out how to locate all of this same data in RStudio. Let's go ahead and start doing that. All right, so there's a very elegant way of doing it. But before we move on to that, let's have a look at our dataset first. So let's look at the financial dataset. As you can see, there's lots and lots of columns here. Let's, for instance, here we were looking at the top 29 rows. We only need probably a top 24 to see all the same things. So let's go and look at the top 24. So we need a head of fin and we need 24. So now if I make some space here, this is exactly the same as we saw there. What do we see? Well, we see some places there are NAs where we saw the red cells. So those are the 4 in a row. There's that 1 over there. What else do we see? Then we've got this empty value here. So it's not an A, it's just empty. So we'll just keep that in mind for now. Then we've got some empties over here as well with the missing industry. Then we've got an NA in brackets. So that's going to be interesting. Why is it in brackets? We'll talk about that. And also employees. So here we've got another NA here. So very interesting. How do we now... What we want to do is we want to single out all of these rows, or we want to pull them out of this data frame, just the rows with missing data. How do we do that? How can we pull these rows out in a very quick and elegant way so that we see them all together separately from the good rows? Well, in R, there's a great way to do it, and we'll need a function called complete.cases. And here, what you need to pass to a function is your data frame, which is fin in our case. And if we run this, what it'll return is a vector containing just true and false values. So it's just telling you basically, this responds to the first row of the data frame. Is the first row complete? Yes. Is the second row complete? Yes. Is the third row complete? False. Let's go check that. Why is the third row not complete? So there's our third row. Something is missing. See, employees are missing here. So it's basically checking if there's an NA in any one of the columns in these associated rows. So as you can see here, that's 6, 7, 8. In row 8, again, we've got an issue. So 1, 2, 3, 4, 5, 6, 7, 8. And here we've got these NAs. So you can see how it's working. It's picking up all of the rows that have at least one NA in them. So that's good. So we have this true and false vector. How can we actually now see the subset of the data frame? Well, we already know about subsetting. How do we bring up the subset here? Very simple. We go fin, right? And then nothing. So complete cases of fin, comma, nothing. So this is a true false vector, which will tell us which rows to pick out. Then comma, nothing. This will pick out only the good rows, so without NAs. What we want is we want the opposite. So we want the negative of this. So basically we want all the trues to turn into false, all the falses to turn into true. So basically this exclamation mark complete.cases fin is all of the rows that do have an NA in them. So if I just run this bit by itself, you'll see that now it's turned into the opposite. So this row is true, this row is true, meaning that there is an NA in there. And so if we subset our data set like that, we will get all of the rows with an NA in them. So what's the first thing that jumps to mind here? Well, the first thing that jumps to mind is that we only have 6 rows. We have 1, 2, 3, 4, 5, 6. And if we go back to the spreadsheet here, you can see that even in this view in the top 24, we already have 7. We have 1, 2, 3, 4, 5, 6, 7, and plus there's more along the way. So there's way more rows than 6 with missing data, right? How come we're only picking up 6? Well, the reason for that is exactly what we discussed. That if we look at our values here, you will see that some of them are just not missing. So they're not indicated as an NA. They're just indicated with empty characters. And that is not the same as an NA, and that's why R, for instance, thinks that this is a complete row, that this value is supposed to be just empty quotation marks, and this is supposed to be also empty quotation marks, so it's not picking them as incomplete rows. So how can we fix that? Of course, we can go through our data set and look for all of these and correct them, but then we'd have to do quite a lot of work. The best way to do this is to actually fix the problem at its core. And to do that, when we import the data, we would need to replace all of these empty strings or empty character values with NAs. So that's why we're going to go to the very top where we imported the data, and we'll say this was our basic import, right? So we'll just comment it out. And now we're going to create a new import, and we're going to say fin read.csv future 500.csv and then comma, and here we need to specify na.strings. So you're telling this function read.csv what strings to replace or what characters to replace with NAs. And so here we're going to pass a vector of values, and in that vector we're only going to just specify one value, which is our empty quotation marks. Basically here you could specify anything. You could say New York, for instance, or any other values that you want R to treat as NAs or to replace with NAs. In our case, we just want all of the empty character strings to be empty characters to be replaced with NA. So that's why we're going to, from here, we're going to rerun all of this code. Oh, well, let's rerun this bit first, right? So if we look at the top of our data set, or let's just look at the top here. Let's give it a bit more. So let's say head 20. So here, now you'll see that in industry where we used to have just missing or just empty characters, now we have NAs. And same thing here, right? So now we just need to rerun everything from here. Let's just highlight all of this code all the way down to where we are now. And so if we run that, give it a few seconds. And now if we run our extract or our subset, now you can see that we're picking up way more rows. And indeed, here we're picking the one up with NAs for industry. And here we're picking up NA. You can see that there were actually quite a lot of them with NAs in the state column. And all in all, this is a much quicker approach than actually going through the data row by row, because you can see that we even had an NA in row 379, which is way down the track. And as you can imagine, it would have taken us a long time to pick it up. So the last question we have for today is, why are some of these rows why do some of these NAs have brackets around them? Why do some of them not have brackets? The answer is very simple. It's basically just because of how R is treating these variables. So if we look at structure of fin, you'll see that the ones that are being picked up with the brackets are inception, industry, and state. And all of these are factors. Industry, inception, and state are factors. And on the other hand, revenue, expenses, profit, growth, and employees, they don't have the brackets. That is because they are not factors. So as you can see, these are not factors. This is not a factor. So essentially, R is just telling us that here the brackets are here just to help us visually see that this is indeed an NA. Because imagine if you had a state like New York. What if there in our data set we had a state with the abbreviation of NA, right? How would we distinguish a true NA, a real missing value from that type of state, right? So that is why R is helping us out. It's saying, okay, you're dealing with categories. So just in case you have a category in there that has the abbreviation NA, I'm going to put these brackets here so that you can see that this is indeed a missing value. So there we go. That's why the brackets are there. And also, most importantly, that's our elegant way to pick out missing rows with missing values. So just use complete cases, then negative of complete cases to flip this logic, and then use that to subset your data set. And also don't forget, so I'm just actually going to take this line from here and I'm going to put it here just so we remember that we updated import to this, because that way we can also see which other values have to be treated as NAs. And it's actually up to you as the data analyst or data scientist to understand which values should indeed be treated as NAs in your data set. And then you just put it in the import, and that way it is much easier to pick out these data. As you could see, it's simply one line of code and we can pick out these rows very quickly. Hope you enjoyed this tutorial, and I look forward to seeing you on the next one. Until then, happy coding. Hello and welcome back to the advanced course on R programming. Hope you enjoyed the previous tutorial, and today we're starting to talk about how to filter our data frames when they do contain missing values. So in this tutorial, which will be a tutorial 1 of a 2-part series, we're going to talk about how to filter non-missing data, so records with non-missing data. So I'll give you an example of what we're talking about today. Let's have a look at our data set and let's look at the top couple of rows, right? And let's say I want to just single out this one row, or every single row that has a revenue of $9,746,272, right? So I'm going to copy this value. What would we normally do? We would go and say, fin, and inside fin, we would obviously, well, let's create the filter first. Let's go step by step, right? So we'd say, let's make some space and we'll say fin $revenue equals this, right? So what does that give us? That gives us a Boolean vector where every row is checked and basically that row is picked out as true. So now if we apply this filter in our data frame, we say fin square brackets, then the filter, then comma nothing. So basically that's our filter over there, then comma nothing. And if we run this, you will see that that row has indeed been picked out. There it is. But also we have these random mysterious rows. Where did they come from? What are they doing here? They don't have IDs. They don't have names. They don't have industries, anything. Everything is NA in these rows. What is going on here? Why have they come up? So the reason why they have come up is because if you look at this filter that we created, it actually has NAs. So you can see an NA here, right? And you can see one over here, it's hiding. So there it is. So that's the N, that's the N over there, and that's the A. So those NAs are coming from the fact that our dataset actually contains values. So if I scroll up, when we're exploring here, you do see that we have values that have, or rows that have NA in the revenue column. And so what happens when you compare fin dollar revenue, right? So when we're basically taking this column, this whole column, and we're comparing it to this value. So there it goes, so R goes through your rows, and it's like, okay, match, so that's true. And then it gets to this one. So for this one, it'd be false, 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 false. But when it gets to this one, what it would say is, oh, okay, I'm comparing 9,746,272 to an empty value. And remember what we did back then? What did we do? We checked that, does this equal to an NA? The answer is NA. It's not true, it's not false. So basically, R doesn't know what to do. Does that row pass the filter, or does that row not pass the filter, because the value is empty? And that's why R tells you about it by supplying these rows. It's telling you that, hey, look, I found this row that you were looking for. The rest didn't pass the test except for two. There are two rows in your data set that had a missing value in that specific column that you're looking for. And so that's how I'm telling you about it. I'm just gonna tell you that there's a whole NA row and a whole NA row again. So I know it might be a bit confusing, like why doesn't R just bring up this whole row with the NA? Well, let's think about it. If what the other option R could do is actually bring up all these values, right? The correct values for that row, and then keep NA here and then correct values here. But that would imply that that row actually passed the test, that row matches our criteria, and that it is one of the ones we're looking for, which is not the case. And so in this way, R is actually protecting us from making incorrect analysis or performing correct analysis, because if we're not just looking at visually, if we're performing some calculation, taking averages and so on, for instance, we're taking the average of the number of employees for all of the rows that contain this desired revenue value, then if it had brought up the correct values here for these rows as well, then we would get an incorrect average. So that's just one of the examples. Basically, R needs to tell you that there's an NA, and this is the best way that they've come up of doing it. So just be conscious of that. If you are filtering your data set, which this is like the standard way to filter a data frame, if you filter your data frame and then there are an NA values, you'll get these mysterious rows come up, which sometimes can cause issues, or even make you like feel a bit uncertain of if your code is correct. So what we're going to learn now is we're going to learn how to deal with this, how to actually filter our dataset the correct way. So what we're going to do is simply, so let's just bring that up. So once again, we're looking for this value in our dataset. What we're going to do is, instead of just performing that filter, inside here, we're going to specify the which operator. So once again, let's probably start step by step. We're going to say which, and then we will put which around these brackets. And what does that do? Well, basically, let's run this first, and then let's run this whole line. So as you can see, we've got just one number here. Where is this number coming from? Well, what which does, let's look at the question mark which. That will be helpful. So let's zoom in here, and it says which indices are true. Give the true indices of a logical object allowing for array indices. And what that means is that which will look through your vector, so this is a vector, and it looks through all of your vector, and it only picks out the values, the true values. So it ignores falses, it ignores that, picks out that, ignores, and the beauty is that which also ignores NAs. So it will completely get rid of all the NAs and all the falses and only return the true value. And that way, you're left with just the numbers representing the correct rows that you want. So basically, now you're going to be passing, once I do this, once I take this filter and pass it to our data frame here, and then comma nothing. So previously, we used a logical vector to filter our data set. Now we're actually passing the row numbers. And as you remember, you can do it either way. You can say, I want fin 3, 4, and 5, right? So obviously like that. That'll give me the third, fourth, and fifth rows. Or I can say true, 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 false, 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 and so on to specify which rows exactly I want. So here we're taking the second approach. Previously we used the true, false vector. Now we're overlaying the which operator or function on top of the true, false vector, which will now return us just the row numbers, just a vector of row numbers that we need to pick out. that correlate just to, or correspond just to the true values. And then once we use that, what we'll get is just that one row that we are after without those NAs. So let's have another example, one of those examples. Let's look at fin or head fin, right? So here what I can see is that, let's pick let's say industry, or no, industry, there'll be way too many. Let's say employees. I know that there's an NA here, and there's I think there's just one NA in this whole data set. So if I pick out all the companies that have 45 employees, let's look at that. So fin dollar employees equals 45, comma nothing. Around that, you'll see that it's picked out indeed 45, 45, 45, 45. Oh, in fact, there were two NAs. So there's one NA here. You can see that there was a company with NA in the employees, and so R gave you these values. And then there was another one, NA1, later further down in the data set. So that's what R does. Now, how do I get rid of these NAs in my final result? Very simple. Let's just copy this line. And here I'm gonna say which of these values are actually exactly true. Run that. As you can see, just the employees, just the companies with 45 employees and no NAs. So there we go. That's the power of the which operator. Sounds pretty funny, right? The power of the which. I hope you enjoyed this tutorial, and we'll continue with this two-part series in the next one. I look forward to seeing you then. Until next time, happy coding. Hello and welcome back to the advanced course on R programming. In the previous tutorial, we talked about the which operator, and we learned how to filter our data frame for rows with non-missing data. And I hope that you had a chance to play around with what we learned previously, because ultimately this is what the course is about. It's about getting as much hands-on experience as we possibly can in order to practice the things that we're learning and to remember them better. And as a quick recap on what we did learn last time is we talked about the which operator, and we found that if we're filtering our data frame for a certain column, for instance, here we're looking for all companies in our data set with 45 employees. And if that column has NA values, then in our subset that we're creating, we'll get these mysterious rows with NAs across the whole row. So there's one and there's another one. Now, in order to avoid that, what we learned to do is that if we apply the which function to our filter, as you can see there, it is being applied there, then we will completely avoid these NA rows, and we will get a very pretty subset of our data that we are after. So today we're continuing this two-part series, and we're talking about using is.na for filtering missing data. So we're basically talking about the opposite. How do we pick out rows from our data set? How do we subset rows that do have NAs? So let's have a look at what we're talking about. Let's look at head fin, and let's say we look at the top 24 rows. And what do we have here? Well, here we've got NAs, here we've got NAs, so missing values. So let's say that I would like to pick out from my whole data set, from my whole data frame, I'd like to pick out all of the rows that have a missing value in the expenses column. How would I do that, right? Well, we actually already know that we can't just compare something to an NA. But let's say hypothetically we forgot that because we skipped to one of the previous tutorials, or this is just our first inclination. What would we do? Well, the first inclination is to go fin $ expenses. This is us creating the filter equals NA. And then we would take this filter and we would put it inside our data frame, comma nothing, right? So just like you would over here, fin $employees equals 45, comma nothing. Here we're just saying fin $expenses equals NA. So let's have a look at this. What will happen over here? Well, let's first look at the filter. What does the filter look like? Aha, so it's not just true false. It's actually all NA. And that is exactly what we talked about previously, that you cannot compare anything to an NA because the result will always be an NA. And essentially, naturally, if you run this filter, run this subset now, you get a very beautiful picture of 500 NAs or 500 rows of NAs. And Yeah, so that is not what we're after, definitely not helping here at all. And as we recall, that is something we have already been prepared for. Once again, we cannot just compare anything to an NA. There has to be a different way. What is that other way that we can finally find these rows that we are after, these rows with NAs in expenses? Well, that other way is through a function, special function that has been created in R. It's called is.na. And this function checks if something is an NA. As simple as that. Similar to functions like is.character, is.integer, is.numeric, and so on. So let's have a look at how it works on a simple example. Let's say we have a vector A of the following values. Let's say 1, 24, 543, then NA, and then 76, 45, and NA again. Right? So there's our vector A. And now if we apply isNA to vector A, what do we get? We get false, 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 true, false, false, true. So exactly what we were after, it's telling us where these NAs are sitting. And now we can use this function to our advantage. We can go ahead and apply it to our dataset. So basically we're going to do the same thing as we did here, but we're going to use the function instead of the equal sign. So we're going to get rid of this double equals. We'll say is.na brackets fin expenses. Run that. Here you can see we get false, 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 true, false, 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 true, and so on. So we're singling out these NAs, and that's exactly what we need for the filter. So now we can simply take this, replace this equal sign filter with this new filter, new and improved filter, and if we run this, we get the exact rows that we're after. All these three rows have NAs in the expenses column. So there we go. It's as simple as that. Picking out rows with NAs. I highly encourage you to practice this. So just maybe pick a different column that we know that has NAs, or maybe we don't even know that has NAs, and maybe try finding those NAs and see if you can pick out columns that, or rows that have NAs. For instance, let's try the state column. Can you pick out the rows that have missing values in the state column using this method? And I'll see you on the next tutorial. And until then, happy coding! Hello and welcome back to the advanced course on R programming. Now that we know how to single out rows with missing values, today we're slowly going to start working on our dataset to either correct these values, remove them, or make other decisions about them. And specifically, today we're going to be removing records with missing data. So let's first go back to our Excel spreadsheet and see which records we agreed that we need to remove. So the ones that we wanted to remove are the ones in the industry column. Because let's say hypothetically, and as you'll actually see further down in this section, we do need the industry column for our analysis. So we can't just keep them empty, and in this case, we can't research the values for these companies because they're actually imaginary companies. So these two options don't work for us. The only option that, well, let's just keep those. Let's just say that we're doing this option. We're removing the lines. And that's what we're going to be working on today. We're going to be removing these lines. And just a quick note, for inception, we're not going to be relying heavily on this information in our analysis. So we're just going to keep the value empty here. So let's go ahead and work on this industry, on these rows with empty values in the industry column. Back to R. And first things first, whenever you're working with data, whenever you're cleaning up a data set, my biggest recommendation to you is always make a backup, because we've done quite a lot of work so far, and as you could see, even sometimes we had to rerun all of these lines. So let's just make a backup of our current data set as it is, so that, you know, if anything goes wrong, we can always restore it from this point. So we're just going to say fin backup, and then we're going to say fin. Simple as that, and that one line can save us a lot of trouble. There we go. Now we've got our backup already in here, and now we're going to look at these rows that we're interested in. So how do we find these rows? First of all, let's look at all of the rows that have some empty values. So we already know how to do that. Complete cases, comma, nothing, and here's going to be fin. You run that, you can see that we've got all of the rows that have an empty value somewhere in one of the columns. And so we only have 2 rows in the industry column that have empty values, and we're going to need to work with them. Of course, we could just look at these rows based on their IDs. So we know that the ID number here, or we can look at the row number and or the name of the company. We could work with it like that. But there's a better approach. Because we do know this is an A function, we can single out these rows by themselves. So let's go ahead and do that. So we'll say fin is.na, and we want to check the industry column, right? So comma nothing. So we want to see which rows have something empty in the industry column. There we go. So there are our 2 rows, number 14 and 15, or IDs 14 and 15. And now what we're going to do is we're going to simply take the same line and we're going to take the opposite, right? So we're going to say which rows are not empty in that specific column. So we're taking the opposite. We run that. You can see that if we scroll up, and we look for our rows, we'll see 10, 11, 12, 13, and then 16, 17, 18, 19. There we go. So those 2 rows have been removed in this representation. And now all we have to do is go and assign it back into fin. So that's how you remove rows. So you first create the subset and then you override the previous data frame with the subset. And now if I look at fin, you'll see that if you scroll up to the top, so scrolling, and here we see that 12, 13, 14, 15 are, so 14, 15 are missing, and that's exactly what we wanted. We have subsetted our data frame. So there you go. It's as simple as that to remove the rows, and we do have that backup in case we made a mistake somewhere. And now if we just look at our complete cases, or look for our NAs, you can see that we have dealt with 2 rows already. They're not in this industry column. You can't see any NAs. And yeah, slowly we're going to get through all of them. Okay, hope you enjoyed this tutorial, and I look forward to seeing you on the next one. Until then, happy coding. Hello and welcome back to the advanced course on R programming. In today's tutorial, we're talking about resetting the data frame index. Now, what I wanted to draw your attention to was that in the previous tutorial, we deleted some rows from our data frame. So if you scroll up to the top, you will see that we have removed rows 14 and 15. They're not here. At the same time, the ID, well, obviously the ID doesn't change because the ID is the associated with the company. So this company's ID is 6, this company's ID is 7, and so on. The ID could have been 100 and or 100,001, 100,002. It's just a number that is coded to the company. But then on the left over here, you see the row numbers. Or in fact, these are the row names for this data frame. And what happened here is that when we deleted these 2 rows, 14 and 15, the name of the rows, of the remaining rows, didn't auto adjust. So you can see 12, 13, 16, 17. And so if you go to the bottom, you'll see that it looks like we still have 500 rows, where in fact we only have 498. And that is something that happens in R, because in fact these aren't row numbers, these are row names. They're associated with the rows. And unlike in Excel, in R, these numbers don't change. So in Excel, if we go here, if I were to delete these 2 rows, right, if I just remove them, you will see that the IDs have been kept for the companies, but then these numbers on the left here, they don't change. So they have been adjusted for these rows. These rows have moved up in the order. So I'm going to cancel that. So I'm going to return these rows. But in R, that doesn't happen. So once we removed 14, 15, these numbers also disappeared. And that is because these are names of the rows rather than like in Excel. They're just a framework of the program that you're working in. And how do we fix that? So the question is, first of all, do we want to fix that? And if we do, then how? Answering the question if we want to is entirely up to you, whether you, for your analysis, require that to be changed, whether for aesthetic reasons you would want to actually keep the correct number enumeration here, or maybe the opposite, you might be relying on this name. Maybe you don't have an ID column and you're relying on this name to pick out the rows, and you don't want it to change. You want it to be associated with the same row all the time, regardless of how you filter, how you reorder your data frame. So it really depends on you. In this tutorial, I'm just going to show you how to do it, because if you do need to do it, then this knowledge will come in handy. All right, so how do we fix up the row names? It's very simple. We've got our data set. As you can tell, everything is actually very simple once we go through it. R isn't, like at this stage, it's not that hard. We're not doing anything complex in R. It's just a matter of knowing these concepts. So here we've got our data set, fin, and we've got row names of fin, which is a vector with the names. And as we know, we can basically assign anything into this vector. We can give them names, like actual character names. Or what we can do is we can just find out how many rows we have in our data frame and then apply that. So we can say 1, 2, and we don't know how many rows we have, but what we do is 498, but the fastest way to count them is n row of fin. So this will give you the actual number of rows you have, 498. This will give you a vector from 1 to 498, and this will assign that vector to the names of your rows. If I run that, you will see that it's 498 here. So that's one of the approaches. Now I'm going to show you a quick tip, or like a hack to this approach, which is much faster. So let's quickly use our backup to restore fin, right? So fin comes from the fin backup. Just to redo this exercise, remove that now. And if I run all of this, right, and now I look at fin, you'll see that once again, this is set to 500. And the fastest way to fix this up is just to go row names fin is null. And now if I look at fin, you'll see that they've been reset. So basically, we're emptying out the names of the rows. We're completely telling R to reset the row names, and by default, it will reset them to this anyway. So this is just a faster way to reset your row names to the correct numeration. Once again, it's really a decision up to you as the analyst or data scientist whether or not you want to do that. Okay, so there we go. That's us for this tutorial, and I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the advanced course on R programming. In this tutorial, we're going to proceed with correcting our dataset, and today we're talking about correcting data through factual analysis. So this is the case where you are able to restore data with 100% certainty. Let's go back to our Excel document and see where this is going to be the case. So here in these states, or in these cases where we're missing the state, we can restore to 100% certainty because we know the city, right? So if we know the city, then we can restore the state, right? Like here, San Francisco would be California. And then also we can calculate expenses with 100% certainty, assuming that there's no fraud and there's no errors, because it is revenue minus profit, basically revenue minus profit. And then once we populate 2 of these columns, we can calculate the third one as well. But we're not going to worry about these for now. We're going to focus on the state column, and we're going to see how we can restore the values in the state column. So let's go ahead and do that. So back to our data set. If I run this line, I will get all of the columns that have missing values. And bear in mind that we have already removed 2. We've removed 2 from the industry. So we removed 2 rows from the data set that had NAs in the industry column. And now we're going to focus on the state column. All right, so what are we going to do? First, we're going to single out all the rows in the state column that have an A. So we can see that there's 4 of them. Let's see if we can single those 4 out. We're going to use fin, and then we're going to use our new type of filter is NA, and we're going to say fin $state. So we're checking for NAs or missing values in this column, and then we're running this whole subset, and there we go. We've got our subset of rows with NAs in the state column. Beautiful. So what do we do next? And now we want to obviously correct them. We want to fix these with New York, NY, and these with California, CA, because New York is in New York, San Francisco is in California. Now we could definitely do them one by one, right? We could do them just based on the ID or row name, and bear in mind that the row name here is now different to the ID because we did remove 2 rows and then we updated the row names for the whole data frame. Now that's one of the ways of doing it. The other way of doing it is to instead of doing them one by one, to actually add an additional filter and say anything that has New York out of this subset, then apply the value. And we're going to take that approach because in this case we have only 4 and we could definitely do them one by one. But in a big data set or in a data set with many more missing values, you might have lots and lots of rows that you need to correct, and working with them one by one can be too tedious. So let's go ahead and see how we can hit both of these rows in one go. This one and this one over here. All right, so what we're going to do is we're going to correct this filter a little bit. We're going to say, yes, we want this subset, but then we want to add another condition. We want to say, and fin $city equals to New York, right? So we're adding an additional condition to that. So if we run that, now we've got all of the ones that have missing values in the state column and their city is New York. And now it's very simple. From here, we just say we want to address the state column. So in quotation marks, because we're addressing it by name. So the name of the column here is state. And we want to say apply the New York code into that column. If we run that, and now if I look at, so how do I bring these rows up? Because if I run this line, they won't come up anymore, right? So if I just run this line, they won't come up because we don't have any rows because they don't have NAs here anymore. So just to check, so we'll just say check. We're going to bring up them by their row names. So we're going to say fin, and here I want to pass on the numbers 11 and 377 because that's the row names. And then I want comma nothing, meaning all columns. Let's have a look at that. So as you can see, the state has indeed been updated to New York. So that is a success. Great, congratulations on that. What do we want to do now? Well, now we want to also quickly check this again and see that now we don't have them. So you can see that this subset is getting smaller and smaller every time we fix up our data set. And now we just need to fix up the San Francisco ones. So I'm going to let you pause the video now. If you want to practice, pause the video and see if you can update these rows on your own. And you need to put in the 2 letters CA into these rows, into the column state. And then just so basically perform the same procedures and then unpause the video and then see how we do it together. So there we go. Now I'm going to continue with this in the video. All right. So now we want to look for fin, basically. Well, fin is in a state. We know that. There's going to be just 2. So there they are. Once again, we could just do it right away now because they're the same city, so the same state. But just for completeness sake, we're going to copy this line. We're going to change this to San Francisco. Run that. Okay, that's good. And actually, we're just going to copy this line. And we're going to say state. Don't forget the quotation marks. And here we're going to say CA. Run that. And now we're going to check. So fin, what were the numbers there? 82 and 265. Okay, so let's have a look at that. 82 and 265, comma nothing. Run that. There you can see that the state has been updated to CA. Okay, and finally, let's just look at this again, just to make sure that it's getting smaller. Voila. So we only have 6 rows left and we only need to deal with 5 of them because we agreed that this one will keep. So beautiful. This one is getting smaller and smaller. This subset is getting smaller and smaller, and that's very exciting. We're slowly preparing our data for analysis, and that's exactly what we are after in this section. And I hope you enjoyed this tutorial. I look forward to seeing you on the next one. Until then, happy coding. Hello and welcome back to the advanced course on R programming. So far we've done quite a lot in our data preparation. I thought it would be nice to mark it off here in our spreadsheet. So I'm not going to worry about the rows that come underneath, that come below, but basically we'll just mark off these red boxes and that will tell us which columns we've dealt with. So we've dealt with the industry column. As you recall, we removed these rows. Then we've dealt with the inception column. We decided to just keep it as is because it's not going to impact our analysis. Then we've also dealt with the state column because we were able to predict or derive with 100% certainty what the state is based on the city. So now we just have a few more left, and today we're going to talk about the employees column. We're going to learn how to use the median imputation method to proxy a value into this column. And we're going to talk about the growth column, and basically the same thing is going to happen. We're going to learn how to use the median imputation method to proxy a value into the growth column. Now I'll explain a little bit more detail what we're doing so that we have a plan of attack for today. So what you can see here is that we've got 500 companies, and if I highlight this row, then you can see that the average number of employees is 148 in across all these companies. And what we could do is we could just take that number, 148 employees, and just plug it into this cell over here. And that is a very coarse median imputation example, or that's an example of a coarse mean imputation, right? So that's not even us taking the median, we're taking the mean, so the average for this column, and we're just putting it in here. So a bit of a step up from that is to take the, rather than for all of these companies, is just to take the companies that are in the retail sector. So let's have a look at that. Let's say I want to create a filter, and then I just want to look at the companies that are indeed only in the retail sector, because this company is in the retail sector. And then if I just go to my column here, now if I highlight all of this, then you'll see that the average is 209. So obviously there are stores where lots of employees are required in the retail sector. So the average has gone up. And now if we put in this number here, 209, that will be a much closer approximation to the reality, because this company does operate in the retail sector. Why would we proxy it with an average across all of the different sectors, including construction, including financial services, IT services? They're not very similar. The companies that are most similar to this company, GreenFacts, are the companies that also operate in the retail sector. So that is an even closer approximation. You could even take it a notch up. You could say, all right, we're going to look at only companies that are in the same state, in the state which has abbreviation SC. So you could do that. Or you could even look at the same city or other things that might impact your analysis. And this comes down to your industry knowledge, so your knowledge of your data set. Does it add value to filter your data set by the same state? Is there more similarities that way, or by year of inception, or maybe by the revenue figures? What will give you the biggest similarity in terms of employees? In our case, we're going to limit ourselves by filtering to the same industry, because that is a kind of a very sure or very certain approach. So it's not 100% certain, but it definitely, like, it even feels like that looking at companies in the similar industries is a bit of a more fair approach than just looking at companies across all industries. If you would like, you're welcome to take it a notch up and look at companies in the same state or city, or use other variables as well. Now that's in regards to similarities. And the other thing is that here in Excel we were talking about the mean, but in reality we're going to be looking at the median, because the median is less affected by outliers. And if you have a massive outlier here in the employees column, so maybe let's just sort it by descending here. So you'll see that we have a company that has 7,000 employees, and it is indeed in the retail sector. As you can imagine, that will skew the average a lot, so it will increase the average. Whereas if you take the median, it won't really impact the median that much, because it's only two values, or in total there's only 9 values out of 500 that are over 1,000. So as you can imagine, they will impact the average a lot, but not the median as much. So that's why we're going to be working with the median values. All right, so there it is. That's our plan of attack for the employees column. The growth column, exactly the same thing. We're going to be performing exactly the same procedures. So let's jump straight into it and get started on this analysis. And actually, I wanted to warn you, these next couple of tutorials where we're going to be using the median imputation method, they're going to be pretty intense, so prepare yourself for that. We're going to do quite a bit of coding. All right, let's get started. So first thing, we want to actually find this median, right? So first thing, of course, if I run this, we'll see that these are empty values and we're dealing with employees. So we have 2 columns here, one in retail, two rows, one retail, one financial services. And so first of all, we're going to find what value we need to put in here, right? We're going to find out the median value, so median, for our data frame, which is fin, in the retail sector. So we want to add a filter, right? So I'm going to put the comma in right away. And here we want, well, right away, we'll just put in the column that we're dealing with, employees, right? So this is just all of the whole column for employees. Run that, there it is. If I run this, that is the median. That's because we've got NAs, and NAs mess up your median. So what we definitely need to do here is na.rm equals true. So remove NAs. If we run that, we can see that the median is 56, and much less than the average. We can just check the mean for the same data, and just to make sure it's the same as what we saw in Excel. As you remember, it was 149, so it's exactly the same as what we saw in Excel, which is good. Now we're going to get rid of that, and with our median, what we want to do is we want to take it to that next level. We want to look at what is in the retail industry. So we're going to add a filter here. It's going to be fin $industry equals double equals. Don't forget it's double equals retail in quotation marks. All right, so that is our median for that industry. So once again, we've got this filter which subsets our data frame to only the retail industry rows. And then we're looking at the employees column, and then we're taking the median of that column and we're ignoring any NAs. So if we run that, we get 28. So as you can see, the median for the whole data set was 56. The median for the retail sector is actually 28. So it is actually the opposite. Very interesting. So that we saw that the average increased when we looked at just the retail sector. So if I replace that with the mean, right, for the average, you can see that the average increased from 149 to 209, but the median decreased. Very interesting observation, and might be a bit counterintuitive as opposed to what we discussed before. But nevertheless, that's the result we want. We want that proxy number. We want this number 28. So what we could do right now, we could put it into that row that we wanted to put it into right away. Like right now, we could put it in there. But a word of caution, it's always a good idea to save these statistics into separate variables or vectors, because before you override the data, because once you override the cells, you've now affected the median. If you want to recalculate the median, then you will already be including that new value that you're putting in there. So it's always a good idea to save these values, and we're going to do exactly that. We're going to put this value into median employee retail. So we remember what column it's for and what filter we applied. It's the retail sector. Run that, and now we've got our median employee retail here, 28. Beautiful. So now what we want to do is we want to replace that row. We want to replace that row with that value. We can address the row by itself using the ID or the row name. But what we're going to do is we're just going to create a filter, just assuming that there could have been multiple rows that we want to deal with. And, that's good practice for the future. So let's go ahead and do that. We're going to say fin, and then we want to say is.na fin $employees, right? So we're looking at the column for employees. We're finding everything that is a missing value in there, and then we're subsetting by that. Then we want to say comma nothing, of course, but we want to add additional filter, because if we just run that, we'll get the retail and the services industry. So we want an additional condition here. We want to say and fin $, where is my $? Here it is, industry double equals retail quotation marks, right? So if I run that, then we have that same one line that we do need to replace for green facts. And now we know we're just going to work with the employees column. We're going to replace that with median employee retail. So if I run that, now we just want to check, and we want to pick out that one row that we were working with, which is row number 3. So let's just run that. As you can see, employees is 28. So we have successfully applied the median imputation method. Congratulations. It's a big step in data preparation, of course. All right, and now we need to do the same exact thing for this other company, which we have here in the financial services sector, which has no employees. So I encourage you to pause this video and practice that. So do the same thing, check for the mean, median, where was it? So just basically check for the mean, median, and everything, and how they change if you include the industry, not include the industry, and then just perform this. And now I'm going to do the same thing here. So now I'm going to basically copy this, and let's have a look at the mean, for instance. Let's see how the mean changes for financial services. So the mean is 211. Well, that's for the financial services. So basically what I wanted actually to do is get rid of this filter. So don't filter the industry, and just for everything, it's 148, then it becomes 211. So it goes up. And now if I look at the median for the same two, what is the median? It was 56, and then it goes to 80. So the median also goes up in this case. Very interesting. Okay, so now what we want to do is we want to just perform the same calculations or same assignments, and we want to create a variable. Here we'll say finserv, financial services, run that, and now we have this, which should contain our 80 value, which is good. And now we just want to assign it. So same as here, we're creating this filter, financial services, right? So there it is. We're checking that it is an NA, a missing value, and the industry is financial services. And now we just working with the same row, but we're assigning the employees column a value which we've saved over here. There we go. So if we run that, and now we have a look at it, check. So financial data set row with the name 330, comma nothing. So Westminster financial services, and we've successfully applied a median imputation method. Again, congratulations. So if I now run this, you will see that we only have 4 more rows to deal with. We're getting very close to completing our data preparation phase. It's getting very exciting. And I hope the median imputation method made sense. It is a very powerful method for lots of different types of analyses. And yeah, I encourage you to practice it whenever you have a chance to, just so that you get the hang of it, and then you see all these ways you can increase your similarity of what you're producing to other records in your dataset. And on that note, I look forward to seeing you on the next tutorial. Until then, happy coding! Hello and welcome back to the advanced course on R programming. In the previous tutorial, we applied the median imputation method to our employees column. And today we're going to start by applying the same method to our growth column. As you can see, we still have an NA in the growth column. So let's go ahead and do that. This should be super quick because we already know what we're doing very, very well. So I'm just going to actually copy this line into here. And now we're going to perform a similar operation to what we had there. So we're going to calculate the median for growth, and it is in the industry of construction. So construction, we're going to, by the way, if you feel comfortable, then you can just pause this video and perform all of this on your own, and then we can compare. So median, finance, dataset, industry, this is going to be construction, and we're not looking at employees, we're looking at growth. And remove NA is true. So there we go, we've got our value. Let's look at the value. It's 10, so the actual average growth in that industry is 10. I actually get very curious, what would happen if I remove this filter? What is the average growth across all industries, right? So if I quickly run this, it's 15, so it's higher. So the construction industry grew less than the industries that, the overall industries. Okay, and that's something to keep in mind. Maybe we could check that later on, just to make sure we're on the right track. All right, so now we're going to say, we're going to apply this value, or we're going to find the value we want to replace. We want to say is NA fin $ growth, and then we want to say and fin $ industry is indeed in the construction industry. All right, comma nothing. So that should bring us that value that we want to replace. Yes, it is, row number 8. And so now we just take this line and we say growth, and we assign this value that we have here. And now we just want to check. It was line 8, so fin square brackets 8 nothing There we go. We can see that the growth has been applied. So now if we run this, you will see that we only have just a few rows left. This one we agreed we're not going to touch, and we have 3 to deal with. All right, so this we're going to keep for later because, or actually let's go back to the Excel. So we've fixed this up. Let's make it green. We fixed this up, and there's a couple rows at the bottom. So we're going to keep this for later because this requires a different method. You cannot just impute it from the averages over here because it has to be aligned with the revenue and profit. So you have to calculate this, and we'll do this in a separate tutorial. And then what we can do is we can impute the revenue and expenses using the median imputation method. So basically exactly the same thing as we did with employees and as we did with growth. All you have to do is calculate the median for the revenue for this industry, or actually let's go back here. So you'll see that there's actually 2 companies in the construction industry that you need to calculate the revenue for. So the only way it's going to be a bit different is that you're going to be assigning 2 values at the same time, but basically all of the code is exactly the same. So revenue, let's calculate revenue, then we'll calculate expenses, and then I will show you how to derive profit for these 2 rows and then expenses for this 1 row separately. So what we're going to do now is how we're going to structure it is we're going to actually, I'm going to end this tutorial here, and that will encourage you to perform this exercise on your own. And then in the next tutorial, I will show you the solution and we'll walk through it so you can check, verify that we've got the same code, and maybe make any corrections if you need to. And then we'll proceed on to the remaining parts. So there we go. Good luck with that. It's a mini exercise. I'm sure it'll come in handy. And I also encourage you not to copy paste the code, but rather to just type it up from scratch. That will give you some additional experience. And I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the advanced course on R programming. How did you go with that exercise? I've got the answers up here, and now we're going to work through them to see what the correct code is. All right, so this is us creating the median variable or vector. So let's go ahead and run that line. And if I look at the value here, then we can see that we've got that is the median revenue for the construction industry. As we remember, we're dealing with these 2 values, and they're both in the construction industry. It's the revenue. So that's why we're calculating the revenue for the construction industry. Next, what we want to do is we want to find these 2 rows so that we can assign this value. So this line accesses the data frame. It checks where the revenue is missing and makes sure that we are dealing with records in the construction industry. So if we run this, we'll get those 2 records that we're interested in. And now if we assign the revenue column this calculated median value, then we will get what we want. So now we can see that even though when we bring these empty or incomplete cases up, they still do come up, but that's because they have other NAs. So that's just kind of helps us check things quicker, so we can see that the values have been assigned correctly. So that's a good start. That's our revenue part. Now with expenses, here I've got a note that we need to be careful here. Only for certain ones, we don't want to replace that one that's by itself, because then that row won't add up. So what does that mean? Well, here you can see that for expenses, we only want to replace this value and this value. We don't want to touch this one because, as we discussed, this value of expenses will be derived from the revenue and profit that we already know, because there's a relationship between these 3 values and we cannot use the median imputation method. So when you come across situations like this, you have to be careful to make sure your filters are targeting exactly the right values or exactly the right cells that you're after. In our case, you will see that because this is companies in a different industry, in the IT services industry, we're not going to, just by the way we've structured this code, it's not going to pick up this row. So we're only going to work with the construction industry anyway. But this is something to bear in mind, and there I'll show you just now how you can add an additional a layer of protection from overriding this row. So let's start by analyzing this code that we have here. So once again, we're creating a variable, median expenses for the construction industry, and then we're saying it's the median of this data frame, which we're filtering just to the construction industry, and we're looking at the expenses column, right? So this all makes sense, removing NA. So if I just run this line, I've got my median expenses for construction. So if I run that, there they are, $4,506,976. And now I'm going to pick up the rows that I'm interested in. So I'm looking for rows that have an empty value in expenses, which would ultimately pick up this row as well. But then I'm filtering it to just the construction industry. So in a way, we're just lucky that this company is not in the construction industry and this row won't pick it up. So if I run that, you'll see that it's just the two construction industries, and that's that. Now, I could just run this line and override the expenses here. But what I wanted to show you is that there's another way that you can make sure that you don't pick up this line. For instance, let's hypothesize and say that this company was in the construction industry. Then what would happen? Then this row would get picked up, it would get overridden by the median, and then this, and this would not add up. We don't want that. So how do we make sure that we pick up only these rows? Well, it's very simple. We just add another filter saying that profit has to also be missing. So as you can see, this column doesn't have a missing profit, and that is kind of the main point of concern. So we just want to say that here we'll just add another filter, would say and is dot NA and then fin $ profit. So we're adding another layer of protection. We're checking that the profit is indeed equal or is indeed missing if we add that here. So if I run this line now, you will see that still, once again, it's just picking up these two rows. And even if I removed this construction filter for a second and I ran this line, you would see that it's still picking up the same two rows because they are the only ones where profit is missing. So this is the proper way, right? This is what we've been doing so far. We're adding this just because we have that additional concern that we might override a row that we're not supposed to override. So there we go. Those are those two rows that we want to work with. And now we're going to override the expenses for these two rows. So let's go ahead and run that. Now, if I look at rows with missing values, as you can see, there's still 4, but we're slowly filling them up. We've just filled up these two values for our construction companies. And now we have just that one more step left to do, and that is to derive the values for these rows. And we're going to do that in the next tutorial. I hope that all of this made sense. Maybe take a quick break, take a pause just to revise this, and especially this part where we added an additional filter. You can add as many filters as you want. It really depends on your data set and what's going on in there, what you see, what you want to replace, what you don't want to replace. So just make sure that you got your head completely around this and you're comfortable with the concepts that we discussed. Maybe try practicing a little bit, maybe rerun some of these lines just to get some additional practice, and then proceed to the next tutorial where we'll finalize this data preparation. We'll just calculate these missing values. And I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the advanced course on R programming. Finally, we're slowly getting to the end of our data preparation phase. As you can see, we've dealt with most of our missing data values in our data frame, and today we're just going to finish up with these remaining red ones. So what do we have here? We've got some, so for instance, in this row, we've got a missing value for expenses, and because we know revenue and profit, we can calculate expenses from that. And also we've got revenue and expenses here, which we've proxied with the industry medians. And from those two, we can calculate profit because profit equals revenue minus expenses. And same thing here, we've proxied revenue and expenses, so we can calculate profit. And that's just an important bit to reiterate that it is your judgment call what to proxy and what to calculate. So if there's a mathematical relationship, then it's better, usually it's better to calculate the value, like in this case. And then if you have 3 values, you will need to decide which ones of them you substitute. So for instance, it shows revenue expenses, and we're going to calculate profit. But always remember about those mathematical relationships, because if you, for instance, if we were to proxy here expenses with the median, the industry median, then these three wouldn't add up, and that might lead to some confusion or inconsistency in your analytics. So let's go ahead and jump into R and finally calculate these missing values. All right, so here I've got the formulas written out. So revenue minus expenses equals profit, and that will allow us to calculate the profit figures. And expenses, if you solve for expenses, then you'll get expenses equals revenue minus profit. That will allow you to calculate this figure over here. Let's jump straight into it. All right, first thing, we're going to filter our data set for any rows that have NA, so missing values in the profit column. So fin $ profit and comma nothing. So that should bring us these two rows. That's correct. And now what we're going to do is we're going to use the power of vectorized operations. We're going to simply take, here we're going to say want to deal with profit. And then we're going to take the same and we're going to say we want, in this case, revenue minus, and in this case, expenses. As simple as that. Nothing more complex needed than that, because this is going to give us a vector of two values, right? NA and A, which we're going to replace. This is going to be the revenues, and this is going to be the associated expenses. So once you subtract the two and then you put them in here, we will get exactly what we want. All right, there we go. And now let's have a look at these records. So we're going to have to remember the numbers. They were 8 and 42. So fin C 8 and 42, comma nothing. So there we go. As you can see, the profit has been populated. And now we're just left with that one record that we need to fix up with the expenses. So let's go ahead and do the same thing. We're going to say fin is.na fin $ expenses, comma. Okay, so we're just finding that one row. Good. Now we want to address the expenses. And what are we going to put in there? We're going to put fin revenue minus fin profit. Okay, so that should work for us if we run this now. There we go. Let's have a look at what line was it? It was line 15. We can see here line 15. So let's look at fin 15, comma nothing. As you can see, the expenses have been populated. So if we look at the rows with missing values, our incomplete cases, you'll see that we only have that one row, which we agreed to keep because it's not going to affect our analysis. There we go. That's how we do data preparation. I hope all of that made sense. And it was quite exciting to get through all of this. I know it was very tedious at points, but I'm sure if you followed along, you learned a lot of new techniques and skills. And I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to the advanced course on R programming. I've got the project brief in front of me here, and I wanted to point out that throughout this whole section, in all of these past tutorials, all we've been doing is preparing the dataset. So we've been working on this bit, that the dataset has numerous discrepancies that need to be addressed before the analysis can be performed. And only now we are proceeding to the analysis and we're going to create these charts and scatter plots. So how mind-blowing is that? That data preparation takes up so much time. Yes, of course, we've been learning, and that has contributed to the fact that it has taken quite a while to go through data preparation. But that is the reality of life in the world of data science. About 70% of the time goes into data preparation because you want your data to be very robust. You want it to have no anomalies. You want to make sure everything is correct before you proceed with the analysis. And that also makes your analysis very smooth and effortless. And that is what we'll see today. So let's proceed to create these wonderful charts now. So I've got our studio here in front of me, and I've even already copied the three charts that we need to create. We're going to start with the scatter plot that is classified by industry, showing revenue, expenses, and profit. So first we're going to connect the ggplot to library. So if you don't have it installed, then you'll probably need to run this line, install packages, and then in quotation marks, you're going to need to type in ggplot2. So just run this line if you don't have ggplot installed. Otherwise, you just need to connect the ggplot2 library, and what you will see here is in packages, Oh, the ggplot2 package, of course. In packages, you'll see ggplot2 has been connected. That's what we want. And then we want to start plotting, right? So first things first, we're going to create a plot. So we're going to say p ggplot and then data equals fin, right? So we're going to set up our data set for our for working with later. By the way, if you're not familiar with ggplot2, then all of this is covered in my R programming A to Z course, and that's where we learn everything about ggplot and how to use it. So definitely check that out if you're not yet familiar with what we're trying to do here. Now we're going to add a layer of geometry onto our plot. So right now it's empty, there's nothing there. Well, I haven't even printed it out. So if I just print it out, you'll see that it's empty. I'm going to add a layer of geometry, which is going to be points because we want a scatter plot. And of course we want aesthetics. So the x-axis is going to be revenue, because what are we plotting here? We're plotting a scatter plot classified by industry showing revenue, expenses, profit. So revenue is going to be our x-axis, expense is going to be our y-axis, profit is going to be the size. So we'll start with revenue and expenses, comma y equals expenses, right? So let's run that. As you can see, we've got that geometry lined up, right? That's good. What do we want next is we want to add some color. So color is going to be industry, and this is all happening inside the aesthetics function because these are aesthetics, or this is a mapping of variables. We're not setting them, we're mapping them. If we were setting them, we would be doing this outside of the brackets. So color equals industry. So if I run these lines now, you'll see that we've got a bit of color, but still they're bleak because they're very small. So here we're going to do size equals profit. So if we run that, much better, right? So because this is a draft chart, we're not going to spend too much time on fixing up the labels and the axes and making it very, very pretty. All we wanted from here is to see the results of our analysis. So we can see that the biggest bubbles are over here where revenue is high, expenses are low, which makes sense. And then you can see how these companies are falling into these industries. So maybe let's make this a bit more space here. So you can see exactly what's going on, that which industry this IT services has. The majority of companies are here. And then you've got kind of like a mix. You've got some government services over here with quite high expenses. The brown ones seem to be here, financial services. So expenses are quite low. And then you got some pink ones over here. So pink is software. We've got some red ones for construction, retail, purple ones are here. So basically any industry you pick from your legend here, you can quickly assess where are they lying in this kind of quadrant representation of all of the companies that we have in the data set. So I'm sure they'll be happy with this chart as a draft, and then you can work on it further to make it look pretty once you've delivered the first draft. Next, what we're going to do is we're going to, using the same plot with the same data, we're going to add some industry, some trends, right? So we're going to do pretty much the same thing. We're going to do point, right? Aesthetics, and here we're going to say X equals revenue. So same chart, Y equals expenses, and color equals industry. Just this time, we're not going to include size for profit because we're going to focus on something else. So let's run these lines for now. And now on top of that, we're going to overlay some smoothers. We're going to say plus geom underscore smooth. And here we want aesthetics. So in aesthetics, we're going to use similar things as we did here. So let's just maybe copy that along. There we go. In fact, it probably would have been easier if we did this. Let's do this. So it looks more elegant. We'll say this is going to be D, plot D. And we'll say data fin, and then we'll just add these aesthetics right in there. So we don't have to copy them twice, and then we can get rid of this, leave some space. All right, so if I run, and then we can just rename this to D. So if I run this, that's our D chart. And here you should see some smoothers. Don't look great, and that's because we want to put fill equals NA and size equals 1.2. So make them a bit wider. Run that again. Much better. So I'll just explain what I did here. I created a new plot, which I called D, the same data set, but it's already got preset aesthetics. Once again, we talked about all this in the basic course on R. So I've set the X to be revenue always whenever I use D, Y to be expenses whenever I use D, color to be industry whenever I use D. Then on top of that, I overlaid a layer of points, which we see here. and then I overlaid some smoothers. So those are these lines that show us these trends. And I've put the fill to NA so we don't see the certainty bands or confidence bands. And then I've just increased the size of the smoother to 1.2. And here you can see some interesting trends. So for instance, here you can see construction. It's going like, it's got this a bit dip. So as construction companies, actually quite a few companies, construction and government services, and bear in mind, these are all made up data sets. So this is purely coincidence what we're seeing here. But as construction companies and government services companies kind of start nearing the $10 million mark in revenue, their expenses start increasing, which eats into their expenses actually start decreasing, interestingly enough. So obviously this is the best part to be, where your revenue is growing, expenses are decreasing. But then as revenue keeps growing further, for some companies, expenses start increasing. For other companies, on the other hand, expenses start decreasing. And here you see quite a consistent trend for the financial services companies. So that consistency speaks to probably that they know what they're doing generally. So they're all kind of on the same trajectory. And the last chart that we need is the box plots. So let's have a look at that. We're going to create a new one. We'll say F, for instance, and F is going to be ggplot. And let's say data equals fin. We'll add the aesthetics as well. We'll say aesthetics. So for a box plot, we need X to be industry. So that's a categorical X. Y to be growth, because that's what we're going to be focusing on. And then we want color to also be industry. So let's maybe get a new line here. Color equals industry. All right, so F is ready. And now we're going to overlay a box plot, geom underscore box plot. Yep, so just brackets, run that. There we go. Some box plot size isn't good. So let's maybe increase the size equals 1, a bit bigger. So here we can see the construction industry is sitting at around 10% in growth, as we saw. And then we've got some other companies, some industries like IT services is up there at the highest, and health is the lowest. No, it's government services, that's the lowest. And probably as a little extra bonus, what I like to do with box plots is I'd like to go F plus rather than the box plot right away. So we can copy this. But before the box plot, what I usually do is I add geom jitter. And for the jitter, we just keep everything as is. So if I run that, you'll see like the points appear at the bottom. And then we just need to correct the box plot a little bit. So we'll say alpha equals 0.5. I'm adding transparency to the box plot. And then these outliers, because outliers get duplicated because of the jitter, we need to get rid of the outliers. So outlier color equals NA. Once again, everything, all of this is covered in the basic course on R programming. So if you've done that course, you are already familiar with what we're doing. We've just created these beautiful box plots that represent the different industries that we've been analyzing, and every single point is a company in our data set, so we can see where they all fall. So there we go. We've got the 3 amazing charts. We've got these are some box plots that those were our trends, and we've also got our scatter plot. So we've got our 3 amazing charts that we can put into our final report for the stakeholders. And as you can see, it didn't take that long at all. After we've done the data preparation, the visualization, data analysis are very, very easy. And I hope you enjoyed these tutorials. I hope you enjoyed the data preparation part and also this visualization quick exercise. And I look forward to seeing you further down in the course. And until next time, happy coding. Hello and welcome back to the advanced course on R programming. Congratulations on completing this section of the course on data preparation. And today we'll quickly recap on what we learned. All right, so let's get straight into it. In this section, we learned, number 1, the factor variable trap. So we had a quick refresher on factors, and we also saw that factors sometimes need to be converted into numeric variables. Sometimes it's the other way around. Sometimes numeric variables need to be converted to factors, and that's easy. But when factors need to be converted to numerics, you have to be careful not to accidentally pick up the actual factor or factorization value. You need to pick up the value which is stored within the variable itself. And we learned how to do that. We learned that you first need to do an intermediary step, for instance, convert the factor into a character and then convert it into a numeric. So that was a very interesting tutorial. Next, we had how to use the gsub and sub functions for cleaning data. So we had examples of fields where there were dollar signs, commas, or even words or spaces, and we need to get rid of them for R to successfully be able to recognize those fields as numerics. So we learned how to do that with these two functions. Next, we talked about methods for dealing with missing data, and we covered off a few methods. We covered off the role with missing data, ignoring the fact that the data is missing, and then some median imputation method. We talked about factual analysis. We talked about calculating. So we covered off quite a few methods, and that's, I think, an important subtopic within data preparation, because inevitably in your career, you're most likely going to deal with missing data, and it's good to have some sort of preparation in this sense. Next, we talked about the NAs. So NAs are a third logical constant, and we went into the very fundamentals of an NA. So sometimes people just know that it's there, but we actually discussed why it's a third logical constant, and we had a few examples of why you can't compare NAs to NAs or to anything else, and hopefully that will lay that great foundation for dealing with NAs going forward in your work with R. Next, we learned how to calculate how to locate missing data. We used the complete cases function. We had a very elegant blueprint for locating a missing data. And then we also learned the filtering techniques, which include the which function and the isNA function. So we use the which function to filter data frames to find records which don't include missing data, and then we use the isNA function to filter the data frames to find records that do contain missing data in the column that we're after. Then we talked about the median imputation method, and there was quite a few tutorials dedicated to this method. So we learned, we had a lot of hands-on experience, I would say, hands-on practice with the median imputation method. And hopefully now after this section, you're very comfortable with it. And not only you know how to replace missing values with the median across the whole data frame, you also now have you should have quite a good understanding of when to look for similarities in your data set. So for instance, if you have columns like industry or maybe gender or something, that categorical type of column where you can group your variables, maybe that's something worth considering, and splitting your data set into those groups and then searching for the median within each group. And that way you might be able to get more accurate results. It's not always the case, but sometimes it can help your analysis. And finally, we talked about the factual analysis and deriving values methods. So once again, we talked about how if you can predict something with 100% certainty, then it's not actually missing data if you can predict it with 100% certainty. And also deriving values methods, where there's like a mathematical relationship. We had a few examples of those, when you can calculate a missing value based on other values in the data frame. And moreover, you should also take that into consideration. So you should take into consideration those mathematical relationships when using the median imputation method, because for instance, we had an example, we had 3 values, expenses, revenue, expenses, and profit, and out of those 3 we could only use the median imputation for 2, and then for the third one we would have to use the deriving values method, because otherwise our data set wouldn't add up. And so things like that you should also take into consideration. So there we go, that was the section on data preparation. Now, we didn't cover off everything about data preparation, and that's because that is virtually impossible to grasp in one course or even probably in a lifespan. There's so much to data preparation. But what my goal was for this section was to cover off all of the main fundamental basics that will give you a taste for data preparation and also give you some of those blueprints, so that when you walk into a project where data preparation is required, you already have somewhere to start with. And then anything else you need, you'll be able to pick up along the way, and you'll be able to also avoid pitfalls like the factor variable trap, because you already know about it. So hopefully you enjoyed the section. Hopefully you picked up a lot from here, learned a lot, and of course had fun along the way. And I can't wait to get started on the next one. And until next time, happy coding.